go to the auditorium. Alrighty. So we're gonna keep on flying, but y'all get me instead of having to watch the video. So we're gonna be talking about polynomials today, and this is just kind of a refresh on what it means. The book is like super pedantic about how like they define it in the nitty gritty. All it is polynomials are based on terms. Monomials are made of one term, usually looks like that. A number, a variable, an exponent. Binomial is made of two terms. It's made up of two monomials added or subtracted together. It is the sum of two monomials, or the difference of two monomials. Because binomial, think about bicycle, 2. Monomial, 1. Trinomial, 3. Exactly right. So it's 3 monomials smashed together with adding or subtracting. It's an algebraic expression made of 3 monomials. A polynomial just has sum. It's not specifically a number. A trinomial is a polynomial. This is some number. I'm just going to put a pound, like number of monomials. Technically, all of these are polynomials. Because 1 is still a number, 2 is still a number, 3 is still a number. A binomial is a polynomial. It's kind of like the all thumbs are fingers, but not all fingers are thumbs kind of dealio. All binomials are polynomials, but not all polynomials are binomials. That kind of thing. So other things that could come up, the degree. Degree is your biggest exponent, the highest exponent value. Of all terms, or all monomials. So if we think about like a quadratic, I'm just going to put it on the dry erase board. So if we think about something like 3x squared plus 2x plus 4. It's a trinomial. It's got 3 pieces. Our degree is our biggest exponent, so it's 2. The same thing if it's a cubic, 4x to the 3rd. Our degree here is 3. It's the biggest exponent. The leading coefficient is the number in front of that biggest exponent. So it's the number. So if we were looking at this kind of setup here, it would be the A.
Here's an answer from
Not
Wikipedia.
you, nosy Nelly. The number in front of the highest degree term. So in our quadratic, our x squared, our leading coefficient, 3. In our cubic, our leading coefficient, 4. Even if they're not in the right order. So if we have one that's kind of scrambled, say we had 2x squared plus 7x to the 5th minus 3x cubed. So even if they're all scrambled, our degree is still the biggest exponent. So our degree is 5, which means the leading coefficient is 7. Okay, so it's all about that biggest exponent. The book spends like 2 pages going through all this stuff, and then it asks exactly 0 questions about this on the homework. So we're going through it just in case it comes back later, but they ask exactly 0 questions about this. It's all about what we're doing with this stuff. Okay, so it's just names for all the things we're gonna work with. But it's a whole page of wall of text. It's a lot. It took me a whole half page on my notebook to write it all out. But what we're gonna do is we're gonna take these things and we are gonna start with adding and subtracting them together. You have done this before. We spent a whole chapter on this in Algebra 2. It's gonna be very familiar. Okay, does anybody need more time to write this page down? I know there's a gazillion and a half words. Okay, and there's a lot of things on here. We are going to add and subtract polynomial expressions. I will zoom in so we can actually see what those terms are. We're going to do 2 adding and subtractings. So make sure you save yourself space for that. So adding and subtracting things like this. We've got ourselves a polynomial here. It's got 4 terms. We've got ourselves a trinomial here. It's got 3 terms. And we've been asked to add them together. It's straight up combine like terms. All we're going to do is combine like terms. When it's adding, there's not even any early steps on it. Combine like terms. So if it helps you to rewrite things in like exponent order, that's totally fine. That's what I don't like to do. So I can take and rewrite it as x cubed plus 4x cubed. Because it doesn't matter what order we add things in. 4 plus 3 plus 2 is the same thing as 2 plus 3 plus 4. So if it helps you to rewrite it and group them together, do so. I'm doing the left one in purple and the right one in this kind of reddy orange. Minus 5x squared minus 5x plus 7 plus 3. So it's the same 2 functions. I just smushed them together so that my cubes are next to each other, my squares are next to each other, and my numbers are next to each other. You do not have to write this step. If you can just combine your like terms, that's totally fine. So we have our x cubed plus 4x cubed giving us how many x cubes? 5x cubes. Sweet. 2x squared minus 5x squared. Boom shakalaka. Minus 5x just comes down because it doesn't have any friends. And 7 plus 3 is... Ta-da! We've added a polynomial. Okay, adding and subtracting, you've done it before. It's just, we just got to refresh. The only thing different with subtracting is we've got to watch out for this minus sign. Because what do we need to do with the minus sign? Distribute it. That's all it is. Distribute the minus sign. So again, if you want to do the rewrite it like I did on the first one, that's totally fine. You can absolutely do that. So we're going to have our 4x cubed minus, let's see, does that show up? I don't like that color. Does that show up? Yeah, that shows up good. Minus 3x cubed. Boop. So we've got our minus 2x squared plus 5x minus 4x minus 3 plus 3. So the sign is the only thing different And now it's exactly the same thing. Combine our like terms. 4x cubed minus 3x cubed, 1x cubed. Our minus 2x squared just comes on down. We got 5x minus 4x plus 1x. Minus 3 plus 3 plus 0, which you can write down, but you don't have to. You also don't have to have these ones. You can 100% do x cubed minus 2x squared plus x. Same deal. You can put the plus 0. It's not wrong. It's not wrong. So adding and subtracting polynomials is just combining like terms. Distribute your minus sign, combine like terms. You've done this a gazillion times, okay? Questions on these two? Because we're going to multiply. And you can multiply in any number of ways. There are, if you did Algebra 1 and 2 with Pike, you may have seen the box. You can box multiply. That's totally fine. Where you write it on the outsides and multiply in, totally valid. We're going to do more of the distribution style in here, just because it'll help us with our factoring that we're going to do tomorrow. But you can do whatever works for your brain. It's not wrong if you box multiply or if you box factor. But we're going to do factoring by grouping, because that's what the textbook wants us to do. So we're going to multiply. I've got a binomial times a binomial. And I'm going to take my 4x times each of these terms. So 4x times 3x gives us 12x squared. And 4x times minus 2 gives us minus 8x. 5 times 3x gives us plus 15x. And 5 times minus 2 gives us minus 10. That's the multiplying part. We've got to finish simplifying. So we've got some like terms in here. I've got like terms in the middle. So we're going to have 12x squared plus 7x, perfection, minus 10. And again, this is something we spent like a whole chapter on in Algebra 2, so hopefully this doesn't feel super different. We are gonna tomorrow work on going backwards and factoring it back out. So we go from the polynomial back to the binomial, or from the trinomial back to the binomials. So we're gonna need to be able to go both directions on this. We're going to do the same thing with this perfect square one over here. We've got minus 3x minus 7 squared, which if you want to write the whole thing out, that's totally fine. The more we can do in our heads, the more time, or at least without having to rewrite as many steps, the more time it's going to save you. Because I know these homeworks are super long. I unfortunately did not get to design them. They're very long. So the more patterns we start to notice and shortcuts we can take, the better it's going to be for us long term, because there's just a lot of stuff in here. Okay, so you do not have to write every step I write. If you can do this next step, like mentally drawing the lines, that's absolutely okay. Okay, just make sure we know how to get where we need to be. And we're going to go... That does not show up at all. I might have to switch off this background because I don't really like this. Oh, that's good. Minus 3x means minus 3x gives us positive 9x squared. Does that show up good? I just said from up here it looks good, but I'm going to look in the back. Make sure we can actually see. Oh, there we go. 9x squared. Negative 3 times negative 3 gives us positive 9. Negative 3x times negative 7 gives us plus 21x. Plus 21x. And plus 49. So again, we need to combine our like terms. Ooh, I guess we can see. We've got our 9x squared plus 42x plus 49. Especially when we're working with binomials, the more steps we can skip, the easier it's going to be to kind of keep up with these giant problem sets that we have, okay? When we get into like trinomials versus trinomials, which is what we're going to do next, where we take like these two guys and multiply, not these two specifically, but like start multiplying these guys, writing out steps is going to help us keep track, just keep organized. But these guys, if we start being able to do it in our head, that would be great. Just because there's so much stuff we have here. And we're going to be using multiplying and factoring stuff a lot. Questions on these two? Okay. Just because this all is review, but it's also been like a year since y'all did this. So it's okay if there are questions on things. Because we're going to do a big one. This is our last multiplying. And it is 2 trinomials. So it's a big chunker. This one, I am going to write a bunch of stuff out. Because it's very easy. If we just are starting to draw arrows, this starts to get real messy real fast. So if we like are just doing with arrows, it gets real messy. If that works for you, that's great. But I'm going to write this out as a set of distribution problems where we take the 2x squared times this whole chunk. So we're going to do 2x squared times x squared minus x plus 4. And then we're going to do 3x times that whole chunk, x squared minus x plus 4. And the minus 5 times the whole same chunk, x squared minus x plus 4. This is, again, not something you have to do. This is just a easy way to keep organized and make sure we don't miss one. Because this has a, it's going to wind up with 9 terms before we simplify. So all this is a way to help us stay organized. If you can do it with the arrows, like if you just draw one at a time, you can do it that way. But if you're unsure, this is a good way to organize yourself. And then we're just distributing one piece here at a time. 2x squared times x squared gives us 2x to the 4th. My brain jumped about 2 words. And that's one of the reasons it helps to stay organized. It's very easy to make your brain, for your brain to jump a step. And then we have 2x squared times minus x, which gives us minus 2x to the 3rd. 2x squared times plus 4 gives us plus 8x squared. And then we get our next one. Plus 3x times x squared, which is x cubed. 3x times minus x gives us minus 3x squared. And we're about halfway through it. 3x times 4 gives us plus 12x. And one more set of terms. See what I mean? It's very easy to get disorganized on this one. Minus 5 times x squared. So we have minus 5x squared minus 5x minus 20. Yes, that would be a positive 5x because that was minus 5 times minus x. Yes. Again, easier to see on this when it's all written out long ways to not miss that sign. If I was doing it in the spaghetti mess up here, it would be very easy to miss one of them and miss a sign, okay? Whatever works for your brain, I'm good with. Your brain has certain pathways you like to take, and I'm okay with you following that pathway. Just make sure you can stay organized, okay? Because especially these trinomials times trinomials, they're a mess. They're a hot mess. And then after this, we're simplifying, combining our like terms, which means anybody that's got the same exponent. We only have 1/4, so our 2x to the 4th is up here. I've got minus 2x cubed, 3x cubed, plus 1x cubed. I've got 8x squared minus 3x squared minus 5x squared. 0x squared. So I don't need to write that one down. I've got 12x and 5x plus 17x minus 20. Yay, it matches my notes. So I don't care if you box multiply or if you distribute or if you write everything out like this or however you choose to do it. Just make sure we can stay organized with it, okay? Whatever technique floats your boat. But these have a gazillion and a half terms. We have one more piece that we're doing today. So we've added, we've subtracted, we've multiplied, divide, but only by monomials. So it's the easy way. We're not doing long division or synthetic division. These guys. Huh? I'll show you easy way. Okay, these ones don't suck. I will zoom them in again so we can actually see what these say because I know they're tiny. So we've got 8x to the 5th minus 2x cubed plus 6x squared, all divided by 2x. Whenever we are dividing by a monomial, so dividing by one term, we've got no adding or subtracting in here. Assume it's been made a common denominator and cut the thing in pieces. Straight up, we're going to make this into 3 fractions. 8x to the 5th divided by 2x. I can't see my sign anymore. That's a minus. Minus 2x cubed divided by 2x. I'm going to erase those because those are in the way. Plus 6x squared divided by 2x. And then look at them individually to simplify. Simplify this guy. Then simplify this guy. Then simplify this guy. And if you need a post-it note to block stuff out, I have gazillions. 4x to the what? To the what? To the 4th. One of those x's cancels out. So 8 divided by 2 gives us 4. X to the 5th divided by x gives us x to the 4th. The minus sign drops down. What does this one simplify down to? X squared. Watch out for the exponents. So 2 divided by 2 is 1. X cubed divided by x is x squared. 6x squared divided by 2x.
6x or 3x.
3x. A little better? Okay. I would say, when you have just one thing on the bottom, no adding or subtracting in the bottom, just cut it into pieces and zoom it in. Okay? Even if it looks crazy. This is our last one for the day. Okay? It looks great. We've got 3m cubed n to the 4th minus 2m to the 5th n squared plus the quantity m squared n squared all over m cubed n squared. Because I know you guys have to write it down. And we're gonna cut it into pieces. Which I have to work really hard not to sing that. Cut fractions into pieces. This is my last resort. So 3m cubed n to the fourth over m cubed n squared minus 2m to the fifth n squared over m cubed n squared. While I'm cutting this into pieces, I'm going to simplify this m squared n squared quantity squared. What are the exponents going to be on m and n? M to the fourth, n to the fourth. When we have a power to a power, we multiply the exponents. Still over m cubed n squared. And then we look at each fraction individually. So this first guy, what is left over when we simplify? 3n squared. Because the m cubes canceled out, and then we subtract 4 minus 2. The minus sign comes down. My 2 is going to hang out because that doesn't cancel out. What are we left with variable-wise? M squared, because my n's cancel out here, and so 5 minus 3 gives us m squared. Bless you. Then my plus drops down. We have m to the fourth, n to the fourth, over m cubed, n squared. m n squared. Now I feel the urge to go, phenomena. Okay? Again, you've done all these things before, but it's been a hot minute. Okay? Tomorrow, we're going to work on remembering how to factor. Because we're going to be using factoring a bunch too. So today we're multiplying everybody out, or dividing, and then we're going to factor stuff tomorrow. So on homework 1-3, these are the ones that don't involve factoring. I'm giving you all the numbers, but I've got the ones highlighted that are what we talked about today. Okay? So we can do up to 36. You might be able to do more, and that's great. And I love that, and I hope you try. But we haven't talked about them yet. Tomorrow we're going to talk about the rest, because the rest are factoring. Okay? So you guys have 10 minutes left where you guys can start looking at this, start working on these questions, ask questions if you got them. Or if you need to finish up 1.2, you can turn that in. Or if you want to work more on 1.2, great. Okay? So